Sit. Anybody else wants to accompany Dheeraj?
No, sir.
Operation is quite less today. What happened?
Yes, I
Go. Good evening, everyone. Good evening, everyone sitting at home also. We'll shortly begin our class now. Okay. So, we have completed first two chapters, isn't it? Discussing the first two chapters. We have completed discussing the first two chapters. Yeah, good evening, everyone. Come in. I just want to quickly ask everyone sitting at home, can you hear me? Everyone sitting at home, can you hear me? Can you hear me properly? Can everyone hear me? Yeah, hello, can everyone hear me? Good evening, everyone. Can everyone hear me? Can everyone hear me properly? Okay. We're about to begin now. Okay. So last day we completed the second chapter, operations on whole numbers, isn't it? How many books do you have? I think only one. We'll be starting our class now, and if anybody has any doubt, we'll be clearing their doubts in the doubt session in the last 15 minutes. Isn't there? Galan? You want to come up? You want to go there? You want to go there? Okay then, let us begin. Your screen sharing. Yeah, Sujan, do you have anything to ask? Sujan, do you have anything to ask? Sujan? Sujan, a little louder, I can't hear you. Sujan? Sujan, a little louder. Yeah, tell me. Sujan, a little louder, I can't hear you. Huh? Okay, we'll be solving those at the end of the class, okay? Okay, tell me second lesson. Self-practice. 10th one. Sujan, 10th one. Okay. You. What's your name? You. Huh? You have the book? You have the book? How many books do you have? Only one? Give his book. They have two books. Take yours. Okay, fine. Settle down. You have got two books. Settle down. You want to say something? Okay, so Sujan asked this question. Since we completed second chapter, let us look at this. This is from chapter 2. This is from chapter 2, question number 10 from self-practice, okay? This is from chapter 2, self-practice. Question number 10. What least number should be added to 64 to make it divisible by 7? Isn't it? What least number should be added to 64 to make it divisible by 7? Okay. So let us look at this. Everyone. The given number is 64. And we have to see what least number should be added to 64 to make it divisible by 7, isn't it? We have to add something to 64. You have to add something to 64. So what do you have to add to it to make it divisible by 7?
6.
Let us first see, if you divide 64 by 7. If you divide 64 by 7,
7, 9, 7.
you will get remainder.
1.
You will get remainder 1. So now the remainder is 1, isn't it? And can anybody tell me what are the remainders you can get when you divide a number by 7? You will get the remainders 0, 1, 2, 3, 4, 5 and 6. That's it. All of this will be less than 7, isn't it?
Yes, sir.
Since you are dividing by 7, so all of this will be
Less than 7.
less than 7. Right?
Yes, sir.
Vaishnavi.
Version.
Varshini. Right? So, now, what will happen if you get some number which remainder is 1, like we got here, isn't it? Then what will happen? We have to add something to it, isn't it? We have to add something to it to make it divisible by 7. And what can you add to it? When is the number said to be divisible by 7? When the remainder is 0. When is the number said to be divisible by 7?
0.
When the remainder is 0.
0.
Right? And when will the remainder again come 0? Basically, all of us know this, isn't it? When you divide a number, the remainders keep on repeating like this. 0, 1, 2, 3, 4, 5, 6. After 6, the next number will again give a remainder
0.
0. Right?
Yes, sir.
Right?
Yes, sir.
So, when will you get the next number which is divisible by 7? When you will give a remainder 0? Which will come after this 6?
0.
Which will come here after the 6?
1.
And we have a number whose remainder is 1. So how much do you have to add to reach there?
0.
How much do you have to add to reach from this?
6.
How much do you have to add? How much do you have to add to reach from this 1 to this next remainder 0? How much?
6.
6.
Yes, sir.
Isn't it?
Yes, sir.
1, 2, 3, 4, 5, 6.
Yes, sir.
Okay. Or you can see it in this way. If imagine you would have got a remainder 7, which you will not get, that will be the same as getting a remainder 0.
Yes, sir.
Right? So, from 1 to 7, how can you reach? By adding 6. Clear? They have asked us what least number? What least number should be added? That means just the next one. And should be added, not subtracted. Don't go this side 0. Don't go the left side, don't subtract 0.
Right. We should
go for the next number, added. So how much will you add here? You will add 6. So which option is the correct option? Option number 2. Isn't it?
Yes, sir.
Clear? Is it clear, everyone?
Yes, sir.
Okay. So last time we completed this chapter, I think. We did some problems from the entrance corner.
Yes, sir.
So here we will be doing problems from the entrance corner. And the self-practice, as the name suggests, it is for your self-practice at home. Right? Okay, at the end of the class, we'll be giving 15 minutes. We'll be having 15 minutes. You can ask me whatever doubt you may have regarding that. Okay? Has everybody started practicing at home?
Yes, sir.
Can I erase the board?
Yes, sir.
Just a second. Okay then. Should we do another question from this chapter or should we move into the next chapter?
Next chapter.
Next chapter. Huh? Next chapter. We have done a few questions from this chapter.
Yes, sir.
Everybody will practice at home and then ask their doubts. Okay. There are many questions for you to practice. There are hints and solutions also, but self-practice we'll be doing. If you have any doubt, you can ask here.
Yes, sir.
Okay. What is our next chapter? Our chapter number 3. Right. Our chapter number 3 is fractional number and fundamental operations, isn't it? And fundamental operations. For example, let us see. Suppose who here loves to eat pizza?
Yeah.
Everyone, isn't it? He can lie, isn't it? So suppose I bought a pizza from any store. I'm not here to sponsor any store. Okay, Domino's or Pizza Hut. So I bought a pizza from a store. Okay. Suppose I'm cutting it in how many pieces?
4, 5, 6, 7, 8.
Count how many pieces?
8.
8 parts, isn't it? So basically, I have made it 8 parts. Now, out of these 8 pieces of this pizza, out of the 8 pieces of this pizza, suppose, what's the name? Paridit. Paridit wants to eat how many? 2.
No, sir, 7.
Fine, we'll give him 2. Sit down. I'm not giving you the real pizza. Okay, it is not a real pizza, you're standing up. Sit down. So, Parinit wants to eat 2 pieces, right? So, out of 8 pieces, Parinit ate how many? 2 pieces. So, basically, he ate 2/8 of the pizza, isn't it? Parinit is also wondering, when did I eat the pizza? So, he ate 2/8 of the one whole pizza, isn't it? Okay. So, this is basically what? We'll say this is a part of the pizza. How much part? If you divide the pizza in 8 parts, Parinit ate 2 of those parts. Parinit ate 2 by 8 part of the whole pizza. Parinit ate how much part of the pizza? 2 by 8. Okay. Then Gagan wants how many?
5.
No, I'll give him only 1 part. So, he will eat 1 part of the pizza. So, he will eat how much of the pizza? 1 by 8. Then, what's the name? Hema. Hema eats, suppose 3 parts. So, she eats how much of the pizza? Out of 8 parts, she ate 3 parts. Isn't it? So, this is basically what we call a fraction. What is the meaning of fraction? It means a part. It means a part of a whole, isn't it? Part of something. So, she ate 3 out of 8 pizzas. How many pieces are done? 3, 1, 4, 2. 6 pieces are done. Remaining 2 pieces. Remaining 2 pieces will give to Mohan Bhaiya, isn't it? Want to give to Mohan Bhaiya? Yeah, so he will eat remaining 2 pieces. 2 out of 8. Okay, all the pieces are over. Finish. Now, if you add all these parts, add all these parts, 2 by 8 plus 2 by 8 plus 1 by 8 plus 3 by 8.
8 by 8.
Everybody knows how to add fractions?
Yes, sir.
The denominator are same here, 8. Add the numerator, 2 plus 2 plus 1 plus 3. 8 by 8. And 8 by 8 is actually equal to 1, isn't it? It makes the whole pizza 1. Okay? So that is basically the idea of what we call a fraction. It is a part of whole. Right? Okay. Now, there are many types of fractions, isn't it? In a fraction, suppose these are fraction 1 by 8. Here, this below part is called what? Denominator, isn't it?
Yes, sir.
And the top part is called numerator, isn't it?
Yes, sir.
We have numerator and denominator. Okay. Now let us look at the different types of fractions, okay? Let us look at the different types of fractions. So, first we have proper fraction. What?
Proper fraction.
Proper fraction. What do you mean by proper fraction? Suppose I write a fraction like this 3 by 5.
Proper fraction.
Here our numerator
Should be less than
numerator is 3 and denominator is 5. So our numerator is less than the denominator. So where the numerator is less than the denominator, that fraction is called a proper fraction. Okay? Yeah. Now what is improper? Improper fraction means where the numerator is greater than the denominator. Suppose I write 19 by 11. Here, denominator is 11, numerator is 19. Isn't it? Here the numerator is greater than denominator. 19 is greater than 11. So we'll call this fraction an improper fraction, isn't it? What do you call it? Improper fraction. Next we have mixed fraction. What do you have next? Mixed fraction. So what is a mixed fraction? Mixed fraction looks something like this. Suppose 7 1 by 3. 7 1 by 3. Here, this part here, or this part is a fraction 1 by 3. Yeah, this part is a fraction, but this part 7 is not a fraction. It is a whole part, isn't it? It's a whole number. The 7 is a whole number, isn't it? And the 1 by 3 is the fraction part. So the part you'll have where you'll have the whole number mixed with the fraction, that we will call mixed fraction. Exactly. Yeah. Huh? What is a mixed fraction? Like that is yeah, because I have it on the board. Na? Your focus is on the chewing gum rather than on the board. Give you some chewing gum later. Okay?
No, sir.
But not now. Are you chewing under the mask? Very good. Will you come into some problem from fraction? No. Huh? Okay. So, this is what you call a mixed fraction, isn't it? Now, we can convert this mixed fraction into our proper or improper. How to do that? How to do that? Yeah, we can convert this mixed fraction into improper fraction improper fraction. It will be improper, okay? How will we do that? First, this whole number 7 will be multiplied with the denominator 3. And then after multiplying, we will add the 1. Basically, it is 7 into 3 plus 1 by 3. This 7 into 3, this 7 into 3 plus 1 will come in the numerator, isn't it? And denominator will remain 3 only. So 7 into 3, 21 plus 1, 22 by 3. Clear?
Yes, sir.
Next we have equivalent fractions. What are equivalent fractions?
Equivalent fractions can be defined as
Let us see equivalent fractions. What are equivalent fractions?
3 by 5 6 by 10.
A little while ago, we had some 2/8 of a pizza. Somebody had 2/8 of a pizza? Yes. What is it? So, Varshini, we know how to do something regarding this fraction.
Yes, sir.
What do we know?
The rate to the 16 to the 4.
First of all, First of all, this fraction 2 by 8, we cannot just leave it like this. Why can we not just leave it like this? Because this fraction 2 by 8 is not in its what? Smallest form. This fraction is not in its smallest form. Why not? Because you have a common factor between the numerator and denominator, isn't it? You have common factors between them. Okay. Basically, we can reduce them further. How? 2 can be 2 into 1 and 2 fours are 8. So basically 2 by 8 can become 1 by 4. Now this is smallest form. Why? Because the only common factor between the numerator and denominator is 1. The only common factor is 1. Clear? Okay. What? The only common factor between the numerator and the denominator is 1. Clear? The only common factor. So this is in the shortest form, right? Now we want to know what is equivalent fraction, isn't it? We want to know what are equivalent fractions. Can I erase the board?
Yes, sir. Yes, sir.
Okay. I'm erasing the board now.
Yes, sir.
Now, what are equivalent fractions? Basically, if somebody asks you, see, if for example, I wrote 2 by 8 and I reduce it to the shortest form 1 by 4. Okay, I reduced it by dividing both numerator and denominator by 2.
Yes, sir.
So I can also make it 1 by 4 to 2 by 8.
Yes, sir.
I can bring 1 by 4 and make it 2 by 8.
Yes, sir.
How? By multiplying both numerator and denominator by 2.
Yes, sir.
So these 1 by 4 and 2 by 8 are equivalent fractions, isn't it? Similarly, if I multiply 1 by 4 with 3 also, it will become what? 3 by 12? So 3 by 12 is also an equivalent fraction to these two. Okay? If you multiply even another number, say 4 or 5 also, it will come out to be 5 by 20.
Yes, sir.
5 by 20, so 5 by 20 is also an equivalent fraction. And so on, etc. Okay? So this is the basic idea of equivalent fractions, where all the fractions can be taken to one same shortest or smallest form. All of them you can reduce all of them to the smallest form 1 by 4. Isn't it?
Yes, sir.
Either dividing by 2 or dividing by 3 or 5. Both numerator and denominator. We all know this?
Yes, sir.
Next we have reciprocal fraction. Is this clear?
Yes, sir.
So I can clear the board. I am about to clear the board now. Just a quick reminder to everyone sitting at home. The meeting will end in 10 minutes. If it suddenly ends, quickly join. Okay, by the same link. Now we are looking at reciprocal fractions. Now what are reciprocal fractions? For example, if I take a fraction 4 by 7. If I take a fraction 4 by 7. Okay, before fraction, if I take any number, say 5. What is the reciprocal of 5? 1 by 5? We all know this? So now for fraction, what is the reciprocal of 4 by 7? 1 by 4 by 7? 1 by 4 by 7? But 1 by 4 by 7, we can write it as 7 by 4. The 7 will go up. How it goes up? Let us see this also. We know the operations of fractions. 1 divided by 4 by 7. I can write 1 by 4 by 7 as 1 divided by 4 by 7. Emma? Varshini? And this will become 1 into 7 by 4. In fraction, when you convert your division, okay? When you convert your division to multiplication, the fraction, what? Goes ulta, isn't it? It becomes the reciprocal. Then the denominator goes up and the numerator comes down. So, 1 divided by 4 by 7 will give you 7 by 4. So, what is the reciprocal of 4 by 7? It is 7 by 4. So, what are reciprocal fractions?
7 by 4.
Reciprocal fractions will look something like this. If reciprocal of 5 is 1 by 5, then reciprocal of the fraction 4 by 7 is what?
7 by 4.
7 by 4. Reciprocal of 13 by 9 is what?
9 by 13.
9 by 13 and so on. Okay?
There are
Reciprocal. Yeah. Fractions. Okay, after this, addition of fractions. Addition, subtraction of fractions, yeah? Okay. Why are you so good? Okay. I'm erasing the board. Okay, now how do we add and subtract fractions? Okay. We'll look at how to add and subtract fractions. Somebody went for washroom. Stay here after he comes back. How do we add and subtract fractions? Suppose you are given something like 7 2 by 5 plus 3 by 7. Okay? Or let's say 3 by what? 2. You are given 7 2 by 5 plus 3 by 2. How will you add these two fractions?
Sir, 5 into 7 plus 5.
First of all, okay. First of all, if you have a mixed fraction, then convert that mixed fraction to improper fraction. Convert that mixed fraction to improper fraction. How to do that? 5 will be in the denominator and it will be 7 into 5 plus 2. Isn't it? What will you get here?
37 by 5.
37 by 5. So this fraction becomes 37 by 5. Now we have to add 37 by 5 and 3 by 2. So you have to basically bring your fractions to improper or proper form, isn't it? Improper or proper form. So how will you add them now? First, we'll take the LCM of the denominators.
5 and 2.
Are the two denominators equal?
No, sir.
They are 5 and 2 different.
Yes, sir.
So we'll take the LCM of the denominators. What is the LCM of 5 and 2?
10.
What is the LCM of 5 and 2?
10.
It is 10, isn't it? Everybody knows how to find the HCF and LCM?
Yes, sir.
Who doesn't know here? How to find LCM? How to find LCM? Huh? You don't know? Okay, let's see. If the denominators are unequal, we'll take the LCM of the denominators, isn't it? I'll make all four of you sit down. Okay. What is that playing with it? Huh? You're not playing. You're not playing. Huh? I've got extra glasses also, isn't it? I can see even clearer. I can see more clearly what I'm doing here. Okay, so what happens when denominators are not equal? We'll take the LCM of the denominators. And you do not know what is the meaning of LCM. What is LCM? Least common multiple. Least common multiple. Let us see. What will be the LCM of 2 and 5, isn't it? What will be the LCM of 5 and 2? LCM means least common multiple. What are the multiples of 5? First you multiply 5 with 1. 5 into 1, 5. 5 into 2, 10. 5 into 3, and so on, isn't it? And so on. Then, what are the multiples of 2? If you multiply 2 into 1, 2. 2 2s are 4. 6, 8, 10, 12, and so on. Now here, least common multiple, isn't it? So which are the common multiples? 10, 10. Then you will find somewhere here, after 12, 14, 16, 18 and 20. You will find this 20 is also common. Okay. So out of all these common multiples, which is the least?
10 and 20.
It doesn't work. So out of all these common multiples, which is the least, which is the lowest? Which is the lowest?
10.
10, isn't it? So the lowest common multiple of 5 and 2 will be 10. Okay. So here we will take the LCM 10. Now, let me write it here, down below. Okay. So, first we took the LCM of 5 and 2, 10. Clear? Now, let us look at this. This 5 and this 10. What do you multiply with 5 to get 10?
2.
Basically, 10 divided by 5 is
2.
2. So, this 2 will multiply now with the numerator. 37, isn't it? Okay. Plus, now look at this 2. What will be 10 divided by 2?
74.
10 divided by 2? 5. 10 divided by 2 is 5. So this 5 now will multiply with the 3, isn't it? 3 into 5. Clear? Now you can find the final answer. What will be the answer? 2 into 37 plus 15, which gives us 89 by 10. Can you cancel these two? Is 89 by 10 is this fraction in the smallest form? If no, then cancel. Can you cancel? You're saying no, sir, no, sir. So this is the final answer, okay? If this is not in the smallest form and if you can cancel the numerator and denominator, basically if you find a common factor between the numerator and denominator, then take it to the smallest form and then you can find a final answer. This is how you add two fractions, isn't it? This is how you add two fractions. Doesn't work. Oh, this is a Okay, so now we saw how to add two fractions, isn't it? Next, we'll see how. Everyone sitting at home, can you hear me? Everyone sitting at home, can you hear me?
Whoever is
It will be possible in 10 documents. Can everyone hear me? Properly? Can everyone hear me properly? Yeah? Can everyone hear me? Yeah? Okay, just a minute. Who is this? Vedraj, right? Okay, just a second. Yeah, ask me, Vedraj, what doubt you have? Sorry? Just a minute. Entrance corner? 12th one. Which chapter? Okay. This is our doubt session now. We'll be doing our doubts. Okay. We'll be clearing our doubts now. So entrance corner number 12. Entrance corner number 12. Chapter 2. Chapter 2. Chapter 2 entrance corner number 12. Okay. Page number 12. Yeah. So here we have the sum of two numbers. What do we have? The sum of two numbers. We are given the sum of two numbers is what? 2, 3, 4, 5, 60, isn't it? The sum of two numbers is 2, 3, 4, 5, 60. If one number is more than the other number by 10,010, by 10,010, then find the greatest number, isn't it? So suppose, see, Vedraj, see, suppose first number we consider x, okay? Then what is the other number? It is greater by 10,010. So if this first number is x, let me write it properly. If this first number is x, then the second number is greater by 10,010. That means it is x plus 10,010. Okay. It is x plus 10,010. And it is given that sum of the two numbers is given as 234560, isn't it? Vedraj? One number I have taken x, the other is greater by 10,010. So it is x plus 10,010. And it is given that sum of the two numbers is 234560. So I can write that x plus 10,010 is equal to 234560. So x plus x will give me 2x, isn't it? Plus 10,010. Plus 10,010. And this will be equal to 234560. Okay. Now, last day we did how to solve such equations and find the value of x. So, if you take this number 10,010 to the right hand side, it will become what? 234560. It is plus on the left hand side, it will become minus 10,010. It will become minus 10,010, yes or no? So you will get 2x equal to do the minus, do the subtraction.
10,000.
It will be 224550. Yes, it will be 224550, isn't it? Now, last day, do you remember? Since 2 is multiplied with x here, when you take 2 to the right hand side, it will become divided by 2, isn't it? It will become divided by 2. So, it will become 224550 divided by 2. You can find the answer of x. It will become, the answer will be 112275. Okay. But wait. What is given in the question? It is given that find the greatest number. Find the greatest number. But here our x is not the greatest number. Our x is this. But the greatest number is this. X plus 10,010, isn't it? So what will be your greatest number? It will be this what you got for x plus 10,010. Is it clear, Vedraj? Is it clear, Vedraj? So after doing this, you will find your final answer, okay? 1,13,285. Sorry, wait. Just a second. You'll find the final answer 1,32,285, isn't it? Option number 3. Clear? Now, from anyone from the offline class, everybody sitting here, do you have any doubt? Does anybody have any doubt? What does it mean? Question number 26. Yeah? Yeah? What, Vedraj? Sorry? Just a minute. Sorry, what? Last chapter? Last answer is 132285, option number 3. Now, what is your name? Bindu. Bindu asked it out here. Bindu had a doubt here from entrance corner, question number 26. Okay. Question number 26 from entrance corner of chapter number 2. Entrance corner of chapter number 2. Okay. Page number 13. Slowly. You want to come and sit here behind the board? Okay, so we have there question number 26. What happened? We have there question number 26 from chapter number 2, entrance corner, page number 13. Okay. This is Bindu's doubt. The product of two numbers is 8192. One of the numbers is 2 times the second number, the smaller number is. We are given what? What is the question? The product of two numbers. What is it given? 8192. Isn't it? What is the product of two numbers? 8192. What is the product of two numbers? 8192. One of the numbers, let us take one number is x. It is given one of the numbers is 2 times the second number, isn't it? So this number will be 2x, 2 times. If we take one as x, another is 2x. Now we have to find what the smaller number is. We have to find the value of x. Okay. So how to do that? X into 2x will become what? X into x? X plus x is 2x. But what is x into x? This is called x square. Okay. What is this? X square. Does anybody know this? Huh? Yes sir, no sir?
Yes, sir.
When you multiply x 2 times, you get what? You can write it as x square. Okay? This is called x square, writing 2 on top of x. Clear? So now, what do we have? So now here we have 2 is there and x into x will give me x square. Okay. X into 2 into x is what? 2 into x square. X into x is x square. Okay. Another thing, if we have x multiplied 3 times, if we have x into x into x, this is called x cube. X cube or x to the power of 3. Okay? The number of times you multiply x, that number you will write on top of x. Here. So 2x squared is 8192. Okay? So what will be the value of x squared? 2 will go down. It will be 8192 divided by 2. So what will be x squared now? 4096. Clear? X squared is 4096. But you have to find the value of x. What will be x? Basically, when I say that x, can you see the board? When I say that x squared is 4096, you can get your book after the class, can't you? Only 1 minute left. Let us finish it, then you can get your book, right? Huh? Or did you ask it out? Just a minute. So x squared is 4096. What is the meaning? It means that x into x is 4096. Basically, you have to find such an x which after multiplying 2 times will get you 4096. Does anybody know what is the meaning of this square root? Does anybody know what is square root? Yeah. That is x square. Okay. So now x into x is 4096. You have to find the value of x. Right. How do you do that? You have to find such a number which after multiplying 2 times will give you 4096. You know how to find the prime factors? Everybody knows how to find the prime factors? 4096, start dividing by 2, isn't it? 2048, then by 2, 1024, isn't it? Then by 2, 512, 2 will give me 256, 2 will give me 128, 2 will give me 64, okay? And similarly you will keep on doing that, and what will you get, you know? What will you get? You will get that 4096 is equal to 2 into 2 into 2 will be multiplied how many times, you know? 2 will be multiplied 12 times. How many times? 12 times. So 2 will be multiplied 12 times. Okay. Now, can I write this as 2 to the power 6 into 2 to the power 6? If you divide 12 into 2 parts, 6 and 6, because this will be what? 6 plus 6, 12? You know that? So, these two numbers are equal, 2 to the power 6 into 2 to the power 6. That is equal to 496. So, what will be x here? It means what? Multiply 2 6 times. After multiplying 2 6 times, what will we get? 2 into 2 into 2 into 2 into 2 into 2, 64. I am not adding 2, I am multiplying 2. 2 into 2, 4. 4 into 2, 8. 8 into 2, 16 into 2, 32 into 2, 64. So that will be your answer, 64. Clear? What else do you have? Exactly similar question I did in the last class. We did number 4 and number 5. Which is in current board 10 marks, model 1 na issue board 5 marks. Take current x. Bhavana will be what? X minus 10 because current 10 x minus 10 Isha will get 5 marks less than Bhavana. Isn't it? Current was x, Bhavana is x minus 10, Isha is another 5. X minus 10 minus x minus 10. Okay. Then x minus 10 and x minus 10. Add all of them, it will be total 170. Then you have to solve the equation and find the value of x. But by Isha is how much? X minus 15. And finding x, what is x minus 15? Okay. Just follow the method. Next okay, everyone, that will be all for today. That will be all for today, okay? This is the end of the class.